So today we're going to be talking about imaginary and complex numbers. So for your whole mathematical life, and we started this school year even talking about it, you had the real number system, okay? And the real number system is this bottom portion. And I gave this to you earlier on in the school year, like I said. The real numbers is any number on a number line. And then that can be broken down into rational numbers, irrational numbers, and then my integers, whole, and natural numbers. We are now bringing in a imaginary number system. Okay, the imaginary number is the value of a negative square root of 1. When you go through and we start solving quadratics, you're going to find that you're going to have to take the square root of negative numbers. But we can't take that, because you want to think about a number squared. If I take 2 squared, that's going to equal a positive 4. Even if I take a negative 2 squared, it is still a positive 4. There is absolutely no way that I'm going to square a number and get a negative. So how is it going to be possible to square root a number that's negative? Well, it's not up until now. Now we have this imaginary number that we're going to replace with I. And by bringing that in, we have now created a whole complex number system. A complex number is basically the two systems combined. It's a real number with an imaginary number. Okay, we're going to talk about in class the possibilities of each of these. But again, if I jump back, remember, this is a flow chart for a reason. Real numbers flow into these options. Imaginary numbers do not. They are their own thing. Okay, so when we start talking in class about can it be whole and natural, real and imaginary, all those things, you want to keep that flow chart in mind. All right, well, what is an imaginary number? An imaginary number, as I said, is this letter I, square root of negative 1. It's going to allow us to simplify radicals that in the past we would just have written no real solutions for. Now we can come up with a solution for it. This table here just kind of shows you what happens as you progress through. If I have an I squared, that is actually a negative 1. An I cubed is a negative I. And I to the fourth is a positive 1. Now, the reason I broke down I cubed and I4 to as you see it, remember, an I cubed is really an I squared times an I. So if I squared is a negative 1, I is a square root of negative 1, then it's a negative I when I combine those two. I to the fourth can be made up of 2 I squareds. I squared is negative 1 times another negative 1 is a positive 1. And we could keep going with this, but it gives you an idea of how our I's can evolve. When you're writing simplified imaginary numbers, be sure to do the following. You want to write the whole number in front of the I, and you write any radicals behind the I. Okay, so it's very important that we write these out correctly. So for example here, I have this square root of negative 4. So if I wanted to simplify that, I would make it the square root of negative 1 times the square root of 4. You just take out, it's simply removing the negative 1. You're factoring a negative out of it. Well, negative 1 square root is an I, a square root of 4 is a 2. So together, I have a 2I. All right, I'm going to do only one more problem with you. If I had the square root of negative 20, again, just take out the negative 1. I have the square root of 20, which that can actually be factored further. I can take it and make it a square root of 4 and the square root of 5, right? Because the perfect square of 4 fits inside there. So now when I look at it all together, I have an I here. That's what the square root of negative 1 is. The square root of 4 is a 2. And the square root of 5, I can't do anything with. So altogether, whole number first, 2, the letter I, square root at the end. I know I kind of squeezed it in there. But that would be how we're simplifying radicals. And we can keep the rest for you guys to practice a little bit later on. Okay, the next set is, let's erase these, our complex numbers. So to do a complex number, like I said before, it is simply combining your real numbers with your pure imaginary numbers. So a real number could be anything that you've ever thought of before. Your pure imaginary numbers is anything with an I attached. When you put them together with an adding or a subtracting sign, they now create complex numbers. Okay. It is important that you write the real portion first, and then you add or subtract that imaginary part. We can do a bunch of things with our complex numbers. We could find out things of solving equations, find out missing variables by simply putting together your reals and your imaginaries. And again, by writing them correctly, you should know that the real portion is always the first part, and the imaginary is always what's added or subtracted behind it. And it will also always have an I involved. So by splitting each into their proper components, you have a simple equation to solve. So in this case, 2x equals 10. Those were my two real portions. They were the first ones written. And my two imaginary numbers, those were the i's. Set them equal to each other, and you solve, and you find what x and y equals. Okay, adding and subtracting or any operations on complex numbers. You are simply combining like terms for adding and subtracting. Add your reals, add your imaginaries. Treat I as a variable, because that's basically what it is. It's a variable that represents square root of -1. When you're subtracting, just make sure you distribute that minus sign before you start combining your like terms. And in multiplying, the thing you want to remember the most is that when you multiply variables, an I times an I becomes an I squared. I squared, as we saw on the previous slides, is a -1. So I can replace, and I will replace, any I squared I see with a -1. So now when I have this problem, 4 times -1 gets me this -4. And all I had to do is rewrite it in its proper standard form, real and then imaginary. I can FOIL to multiply out larger complex numbers. Oops, sorry. So when I multiply, my wholes, my reals, then I multiply the imaginary to a real, so forth and so on. I have all this. Again, you're just going to combine your like terms. Any I squared is going to turn to a -1. Use that to replace it. So basically, you're always changing the sign of the real number attached to an I squared. And then, as we do always, combine any like terms in the end, making sure it's in standard form. Okay, and on this page, it's just a bunch of problems practicing each of those. So what we're going to be getting into next is when we start solving our quadratics, we are going to have these values that we're going to have to simplify, and they may have imaginary numbers. Anytime we square root a negative number, we need to make sure we don't forget to put that I value in there.